Hi, and welcome to another Intro to Java Programming video. In this video, I want to talk about making calculations with primitive data, primarily working with just ints and doubles. It's assumed that by now you've watched a video on primitive data and on variable use and things like that, so you know what these things are and how they work. Now I want to talk a little bit about making calculations with these primitive data. You should open this class in your IDE. It's called Calculations. It's along with the lecture files for Unit 2. And you should find this calculations file. It has the main method only, so it's not a graphical application. Sometimes I do things in the main method and output using these system out println statements just because it's quicker and easier than doing something graphical, and it'll give us the kind of output results that we want. So what we have here inside the main method is I've got a series of variables up at the top. Now, when I make variables, I usually put them up at the top so that they're accessible to everything below it. When you think about the way a program processes, and we talked about this in the first unit, it processes from top down, and it'll parse each line as it goes. And if it doesn't have access to something down here, then it can't work with it. For example, iResult, I1, and I2 are right there. So if I have iResult and I decide to declare it down here instead of up here, you can see that I've got a problem. Declaration has to happen before we can use a variable. You should know that from the using variables videos and from things on primitive data and stuff like that. So that's all I'm going to talk about that. Now I want to move into the calculations portion. The way this works is you've got an assignment statement, and on the right side of that assignment statement is where you make your calculations. The left side of that assignment statement is the variable that calculation gets assigned into. So the way this works is everything on the right side of the assignment statement gets executed, you get a result, and then that's assigned into the variable on the left side. That's how calculations happen. Calculations that we can do are any of the kind of arithmetic calculations that you can think of, from addition to subtraction to multiplication to division. There are other types of calculations we can make called incrementation, decrementation, and we also have the ability to calculate the remainder of a division operation as well. I'm going to start with addition and subtraction because they're quite simple and there are no funny rules that go along with them. I've got two simple calculation statements here, assignment statements with calculations on the right side. I've got addition and I've got subtraction. These arithmetic operators are binary operators. In other words, they take two operands. An operand is anything on either side of an operator. So we would say I1 is an operand and I2 is an operand. They're both being operated on by the plus operator here. Now, I1 is 2, I2 is 16, so this 2 plus 16 should resolve to 18 and get stored into there. Let's see if it does what I think it is supposed to do. I'm going to run this program. And I'll go up to the very beginning. Okay, here's my output statement. My output statement says system out println, iResult is assigned the value I1 plus I2, and this is just a string literal. No calculations are being done with this. Anytime you see this green in my IntelliJ, it is just a string literal. It's a series of characters, and it's not a number or anything like that. Then I've got the plus operator here. The plus operator is for addition, but it's also used when there's a string involved for something called concatenation. What's happening is this variable here holds an int, and that int, which stores the value 18 right now, is being concatenated or joined on to the end of this string, and then it's output in this println statement. So what we're getting here is iResult gets I1 plus I2 colon space 18. So the 18 that's in here, that is the result of this summing operation, gets concatenated to this string and passed to the println statement and then printed out. Okay, you're going to see me do this kind of concatenation a lot. You're going to have to use it a bit in this units project as well, the measuring distances project. Now I've got a subtraction operation here where I'm subtracting I2 from I1. I2 is 16, I1 is 2. So if I subtract 16 from 2, I should get negative 14. So my println statement, I've got iResult gets I1 minus I2 plus iResult, which is negative 14. You can see my output statement is right there. It does what you think it would do. Okay, so my operation takes place here, and then I output it right here. In this week's assignment, you're going to do calculations to find the distance between points, and then you're going to use the draw string in order to display the results on the screen. Let's take a look at some other operations. Multiplication and division. Multiplication does exactly what you would think it would do. So if I multiply d1 by d2, that is 2 times 16, I should get 32, right? 2 times 16 is 32. So down here I've got my println statement. D result gets d1 times d2 plus d result. And that means it'll just take that 32 and concatenate it on there. Let's look at our output and see if it gives us what we think it'll give us. Oh, this doesn't look correct at all. It says d1 plus d2 is 8.125. Where did I make my mistake? I said d1 was 2 and d2 was 16. Was I correct on that? Let's look at our variables. I wasn't right, because d1 is 2.5 and d2 is 3.25. I was confusing my d1 and d2 for I1 and I2. That's a common mistake, getting your variables confused. This can happen if you have bad variable naming convention. What does that mean? Variable naming convention is a way that you name your variables. You want to name your variables in ways that are going to be descriptive of their job. Otherwise, it can be really easy to confuse them. So I got confused. D1 is 2.5, D2 is 3.25. When I multiply 2.5 by 3.25, I get 8.125. So I do that multiplication. It gets 8.125. It gets concatenated onto this string here, and it outputs. Now, what you learned from a previous video on data types is that double is a floating point type. In other words, it has the ability to store decimal information. Integers, on the other hand, cannot. Ints can only hold whole numbers. These ones can resolve in decimal numbers or fractional numbers. Now, let's do the next one. What happens when you divide a small number by a big number? Well, normally you just get a long decimal, right? So when I divide the 2.5 by 3.25, which I'm doing right here, I get 0.7692 and then some trailing decimals all the way out here. A double has quite a lot of precision. It's got quite a few points of precision here. So that's my division operation. Multiplication and division with doubles is very straightforward. Let's take a look at the modulus operation. Modulus operation does division, and then it gives us the remainder of that division. Okay, so I2 divided by I3. I2 is 16, I3 is 7. So 16 divided by 7, 7 goes into 16 two times, that gives us 14. That gives us a remainder of 2, and you can see the result right here is remainder 2. So this is called the modulus. It gives us the remainder. It does a modulo operation. You may have learned about modulo operations in some of your math at some point. Here's another one. I2 divided by I1. The result is 0. And let's see why. I2 is 16, I1 is 2. So 16 divided by 2 gives us 8 with no remainder left over, so that would be 0. That's how our modulus operator works. Now let's try something else. I'm going to go the opposite. I'm going to go I1 remainder I2. I'm going to just flip this around. I'll go I1 remainder I2. Now I1 is 2, I2 is 16. So I've got a small number divided by a big number, and I'm going to check to see what the remainder is. Here we go right here. The remainder is 2. Now let's think about why that is. So 16 goes into 2 0 times, and there's a 2 left over in that operation. So that 2 is my remainder. It's 0 remainder 2. Okay? So when you do remainder operation with a small number divided by a big number, that's what you get. You always get the small number in return. All right, let's look at some of the compound operators that we have access to. We've got the plus a sign operator. And what this does is it will take the value of d result, add it to d2, and then assign it back into d result. This statement here is equivalent to this statement here. So anytime you're doing something like this, you're summing a value into a variable and putting it back into that same variable, I would just use this compound operator. Now these compound operators work for addition, subtraction, multiplication, division, and modulus. All of them have those compound operators. So, you know, this is also a thing here. Multiply a sign. This is also a thing. Divide a sign. Subtract a sign. Mod a sign. These are all different compound operators. Okay? So get used to those. Those are equivalent to this type of statement. This is our incrementation. Incrementation is equivalent to, it's equivalent to this statement right here. Same thing as I result gets I result plus 1. You're adding 1 to the current value held in I result. It's the incrementation operator. You're going to see this a lot, especially when we get to things like loops. This is our decrementation operator. In other words, it takes 1 out of the value of that variable. So it decreases it by 1. These are called the post-increment and post-decrement. Now, I'm not going to go into detail on what this is, but this is the thing as well. It's called the pre-decrementation. I'm not going to even try and explain it here because you're not going to use it in this class. It's not important for this class, but you will learn it in your upper division programming classes because it does the incrementation and assignment in a different order, and it can really have drastic results on the way that your program functions. For now, just worry about the post-incrementation and post-decrementation instead of the pre-incrementation and pre-decrementation. I just wanted you to know that they are a thing. All right. Now, calculations with int problems. We get problems when we do division with ints. There are 2 problems that arise with division with ints. If you divide a small int by a large int, what happens is it resolves to 0. If you divide a int with another int and it doesn't give you an even result, you don't get the decimal. Remember, integers or ints can only hold whole numbers. They can't hold decimal information at all. So instead of doing any kind of rounding or anything like that, what happens is truncation. It just chops off the decimal. It doesn't round up, it doesn't round down, it just chops the decimal off. So let's look at I2 divided by I3. I2 is 16, I3 is 7. We already saw that 7 goes into 16 2 times. So this operation here would resolve in 2. It wouldn't be 2 point something, because the point something gets chopped off. We don't round up, we don't round down, it just chops it off. Now I1 divided by I3. I1 is 2, I3 is 7. 2 divided by 7 would give us point something, right? Well, when we're working with ints, it doesn't. Ints cannot hold that point something, so we lose precision. It's going to chop that decimal point off and just give us 0. So the result of this operation here would be 0. The result of this operation here would be 2. And we can see that evidenced right here, 2 and 0. Now, let's take a look at this operation here. This is a long calculation. You're going to have to do these types of algebraic calculations. And in this week's assignment, you're going to have to do something longer like this. That's going to use square root and exponentiation, and you're going to have to use parentheses. You're going to have to add and subtract and multiply. All that stuff is going to be used in the calculations this week, so you better know how it works. In Java, calculations happen with the same rules as algebra for the most part. In algebra, we've got that mnemonic PEMDAS, right? PEMDAS, which stands for parentheses, exponent, multiply, divide, add, subtract. And your operations are done in those orders. Well, in Java, we don't have an exponentiation operator. In other words, there's no operator that allows us to square something or cube something or raise something to the 4th or 5th power. There just isn't. There's a method that does that, and we'll get into those methods in a future video. But for now, for calculations, what we do is we always do the innermost parentheses first. So we would resolve this set of operations. Then we would do multiply and divide on the same level, then add, subtract on the same level. So in here, I would do D3 times I3, and I'd subtract that product from I2. I would get those calculations there, and then I would resolve these parentheses here. I would divide I2 by I1 and sum that with the result of these parentheses. Those parentheses would be totally resolved. Then I would do these parentheses here. I would do D2 divided by I3 and then sum that with D1. I would take this result and multiply it by this whole result. So once again, the order of operations would be multiply, subtract, divide, add, divide, add, multiply. And then I would get this result here, negative 188.232 and some change going all the way up. Okay? So that's the basics of calculations. In short, calculations happen in Java just like they do on paper and pencil with math, with some differences. Ints are funny. Ints can only hold the whole numbers, so they always give you whole number results. If they resolve to something with a decimal point, it truncates the decimal. If the value is smaller than 1, it truncates the decimal and just gives you 0. Otherwise, all of our operations happen as they would normally on paper. All right, thanks for watching this video, and tune in for more videos dealing with math methods.